This video lecture explains about Knapp's classification of distributed deadlock detection algorithm. After completion of this video lecture, the students will be able to uh, understand the concepts of the classification, Knapp's classification of the distributed deadlock detection algorithms. The algorithms are path pushing algorithm, edge chasing, diffusion computation, and global state detection. First, see about the path pushing algorithms. In path pushing algorithm, the distributed deadlock detection are detected by maintaining the explicit global wait for graph. The basic idea is to build a global wait for graph for each site of the distributed system. At each site, whenever deadlock computation is performed, it sends its local wait for graph to all the neighboring sites. After the local data structure of each site is updated, this updated wait for graph is then passed along to other sites, and the procedure is repeated until some site has a sufficiently complete picture of the global state to announce deadlock or to establish that no deadlocks are present. So this feature of sending around the paths of global wait for graph has lead to the term path pushing algorithm. Second algorithm is edge chasing algorithm. The presence of cycle in the distributed graph structure is verified by propagating special messages called probes along the edges of the graph. These probe messages are different than the request and reply messages. Whenever a process that is executing receives a probe message, it discards this message and continues. Only blocked processes propagate probe messages along their outgoing edges. The main advantage of this algorithm is that probes are fixed site messages which are normally very short. Next algorithm is diffusion computation based algorithm. In diffusion computation based distributed deadlock detection algorithms, deadlock detection computation is diffused through the wait for graph of the system. These algorithms make use of echo algorithms to detect deadlock. This computation is superimposed on the underlying distributed computation. If this computation terminates, the initiator declares the deadlock. So, to detect the deadlock, a process sends out the query messages along all the outgoing edges in the wait for graph. These queries are successively propagated through the edges of wait for graph. Queries are discarded by the running process and are echoed back by blocked processes in the following way. That is, when a blocked process receives first query message for a particular deadlock detection initiation, it does not send a reply message until it has received a reply message for every query it sent. For all subsequent queries for this deadlock detection initiation, it immediately sends back a reply message. The initiator of the deadlock detection detects a deadlock when it has received a reply query it has sent out. The last algorithm is global state detection based algorithm. Global state detection based algorithm exploit the following fact. That is, a consistent snapshot of a distributed system can be obtained without freezing the underlying computation. If the stable property holds in the system before the snapshot collection is initiated, this property will hold in the snapshot. Therefore, distributed deadlocks can be detected by taking a snapshot of the system and examining it for the condition of a deadlock. So these are the possible questions may ask. That those are the state of Knapp's classification, define probe, and what is the use of query messages. Thank you.